Eugene is a software engineering manager at Bodybuilding.com with over 15 years of experience building high-performance, high-traffic web applications. He is currently responsible for Bodybuilding.com's content platform, utilizing DevOps principles to achieve rapid development, performance, scalability, and automation across the architecture. Please welcome Eugene.
Microphone. This one in?
Yeah, just turn it on.
All right. Anybody hear me? Good. All right. So first of all, welcome everybody. I'm really happy to be here today. Big thanks to Paul and In Time Tech, as well as the Idaho Technology Council and Zions Bank for putting this on. When I first found out about it, had already been planned. It was already sort of set to go, but it was such a great opportunity. So even with this sort of short notice, I was just thrilled to be able to come on and just kind of share some of the things we've been doing, challenges we faced, and some of the things we've been working on around DevOps. So, as Paul mentioned, I'm engineering manager for Bodybuilding.com. I've been there about 8 years. My background, software development. About 2.5, 3 years ago, I moved into management. That's what I'm doing currently. But I'm fortunate at Bodybuilding, we're a very technical company all the way up the chain, and so I still get to write code every single day, which is a really, really nice thing. So what I'll be talking about today is some of the things we've been doing with DevOps, particularly around our content platform, and a couple, you could sort of say, experiments that we've done internally to try and move us towards this more DevOps culture and sort of DevOps process. So why do we need it? So just looking back to sort of how we were doing things in the past, deployments were slow, right? So we've got a dozen teams. They're all going through some of the things that we've covered today. So we had continuous integration. We were following some of those best practices, some of those DevOps practices. But there was a point where we got to a single stage environment that became the bottleneck for a lot of things for us. And so it became a sort of an exercise of developers are committing their code, they're testing it, all that looks good, but then it comes time to coordinate with all the other teams around this finite resource before you do the final vetting for your application for it to get into production. So things were just slow. You had things like deployment calendars. You had things like merge days that you had to worry about just in order to coordinate all those different pieces. So again, competing for resources, right? There's this big funnel, and I'll show a slide here in a second, what that looks like. A ton of teams all competing for the same resource, trying to get into production with their software. And then a couple of people have already touched on this. We were starting out with some really large systems, right? They were just monolithic, they were difficult to maintain, and so we needed to do something about it. So this is what that old way looked like for us, right? You got all the teams, it goes into that deployment pipeline, and then it's sort of an effort between dev and ops. And that line of where the responsibilities start and end was also very fuzzy. So it created just that bottleneck there. And then the worst thing is fine, you get through all that, your code's in production, now what, right? Gary stole my thunder earlier. He said, what's the worst that could happen, right? So you've all been through this, I'm sure. That's what happens, right? You get your code tested, you get it deployed, and then you don't really worry about it anymore. You got an operations team that's there to manage it, and you don't get the call in the middle of the night when something goes wrong. So what we're aiming for is something more like this. And the idea was to sort of break out our applications into smaller services, just smaller pieces that allows the team itself to handle that entire development and deployment pipeline all the way out to production. And once it gets to production, the team's responsible for it as well, right? There's no one to call when something goes wrong in the middle of the night. Every single developer on that team is on the on-call rotation. So that sort of forces developers to think a little more about what they're developing, the quality of the work, their testing that they're putting into it, because at the end of the day, they're the ones responsible for it. There's no one else they're going to call when something goes wrong. So how do we accomplish this at Bodybuilding.com? So one of the ways was really just empowering developers, right? Removing those restrictions on those shared resources and really just duplicating all those resources so that they really have complete access to the code as well as the testing phase, the deployment phase, and then managing it in production. So I know that sounds scary, but if you think about it from the point of view of the way you architect your system and some of the stuff that I'll be demoing around automation, I think this becomes less and less of a concern. Like I mentioned, that also, along with that comes full responsibility for what happens. So they have the freedom to choose how the system is architected, the software they use. They have the freedom to choose, for example, even the smaller things like what logging system they want to use or what monitoring system they want to use. But they also are fully responsible for it. And I know that sounds a little bit chaotic at first, but what we found is as you have more teams coming onto this and learning and experiencing this themselves, sort of the best of ideas just kind of bubble up, and some of those better ideas win. So it sounds chaotic at first, but in the end, the good ideas tend to win, and that it fosters that collaboration between the teams, and so it tends to work out. Again, if something goes wrong, if you didn't do it right, there's really no one to call. And again, the amount of work that you put in up front before your code goes to testing and production, right? I mean, that's what's going to ensure that your application is stable, functioning, can scale as it needs to. And it sort of puts that focus back on the dev team to make sure they're writing quality software. The other thing that we instituted, so I mentioned earlier that we had this sort of process and a deployment calendar, and everybody's got to sign up, and you want to ship, a couple weeks from now, you get on the calendar, you get your testing done, it goes through all the phases, and then, hey, it's your day to ship. With a new model, it's really up to the devs, and they ship multiple times a day, and I'll share some stats at the end. Last year, 2015, I had some stats readily available for that. We did somewhere around 2,300 production deployments. So it's really a result of just empowering developers, allowing them to have full control of their systems, and as well as manage them. How many are doing anything with AWS? How many of you have actual production systems, at least one in AWS? And how many of you can spin up a dozen of them programmatically or via some automatic process? Excellent, good. So that's really the key that really enabled us to accomplish what we were trying to do, right? You've got to be able to automate every aspect of it. If you're logging into a system or doing anything manually, it's just not going to work. It's not going to scale. And then finally, monitoring. So Gary talked about it as well. It's great if you can spin up these systems and they automatically come online, they start serving traffic, but you've got to know what's going on with them as well. So for us, monitoring was a big part. How do we tie that in to this automatic scaling and sort of automatic just provisioning of things? As soon as they come online, they have to be monitored. You have to be able to see a dashboard, see what's going on with them, see what kind of traffic they're taking, and that shouldn't require any manual steps from anybody to accomplish that. Just thinking through some of the challenges that we've had as we've sort of transitioned to this model. And just for full disclosure, we're still not there yet, right? We still have parts of the business that are running sort of this old way, and we're making the migration to this new way of thinking. But there are a couple things that kind of stand out to me looking over the past year or so as we've been moving towards this. It became really obvious really quickly. It's where do you draw that line, that separation of duties between the ops and the dev folks? And one common thing is when people first approach this is that it's sort of, a point of contention between dev and ops, and it shouldn't be, right? At the end of the day, you're on the same team, you're really complementing each other, you're working as a team to accomplish these goals. But you still have to sort of define which of these tasks or which of these sort of pieces of the architecture need to be owned and by whom. So what we found is it's great to give developers and empower them to be able to manage their systems and deploy and scale them. But there's some really fundamental things like security, right? Those kind of things we found that are better managed or at least have to have some sort of oversight from a sort of a central group. So we have a central group that sort of is responsible for defining what those are and laying out some of those requirements for the teams. So when a team wants to spin up a new application or put something in the cloud, it doesn't dictate, well, you have to use this piece of software, you have to use this logging system, or you have to use this web server. But it does say you have to account for these things. You have to have your systems being logged. You have to have your systems being monitored. You have to have the logs being copied off somewhere. From a security point of view, you have to make sure that your systems aren't open, that SSH is not open, things like that. So it's not about dictating what or the specifics of what needs to be done, but laying down the groundwork and defining that these things have to be done. Particularly around AWS, multi-factor authentication and just limiting access to the system proved some challenges initially, and just kind of laying out what that looks like, right? I think a lot of, especially smaller companies, when they start out, they go into AWS, they create a few accounts, they have some keys that they use to do things, and that's really it. They don't really think about the security model overall. So if those aren't properly locked down in terms of security and what those scripts are allowed to do, that can lead to some issues pretty quickly. So defining that ahead of time, I think, is a really good idea. Again, the infrastructure design and how you lay out your VPCs, your subnets, IAM roles. IAM roles are very important, especially when it comes to AWS, how you manage your security, your systems, access to things. And if you don't think about that ahead of time and put some and really set some guidelines around it, I think you're going to have a bad time. And then finally, consider your resources. So a lot of companies want to move to a DevOps model. They want to be a lot more flexible and agile, but they may not have the resources to do that. People, especially older, sort of larger companies, are sort of set in their ways in terms of doing it the old way. And so you have to consider the resources that you have. And so I think what you have to think about is it may not make sense to sort of bite it all off and do it all at once, right? Just take baby steps and sort of move into it until you can sort of build up that bench strength to sort of accomplish it the way you'd like in the long run. So what are some of the benefits, particularly to us? Shorter development cycles. A couple folks have already talked about it. Instead of having this long deploy window and this long process of we've got some code written, we want to test it, we want to get out, got to get on the calendar. Break those up into smaller, smaller commits, test them individually, test them well, and then push them out as needed. And this leads to really just smaller issues to deal with, right? One huge commit, you get towards the end of the pipeline, it's ready to go out, you have a merge conflict. That's a big deal to have to unwind and roll back. Tiny, small changes, and a couple folks have already mentioned it, sending out benign updates that you can flip on with a configuration or something really helps in just making it an easier flow and just smoother in general. And again, rollbacks or roll forward. We tend to roll forward when we run into issues. And if you have a system and a process that's designed for that you can very quickly execute on, and you don't have to worry about being in a queue and waiting your turn for resources, then it makes that a lot easier. Reduces bottlenecks, of course. The team is completely empowered from beginning to end. They write it all, they test it all, they ship it all, they're responsible for all of it. So devs are empowered, and more importantly, they're encouraged to experiment, right? They are sort of, in one sense, especially when you're talking about building microservices that interact over APIs that are versioned, the likelihood of affecting somebody else is lowered in a lot of cases. And so it gives them an opportunity to try something out. And if, again, as I mentioned earlier, if that approach works, the devs are talking, they're communicating, they're collaborating, and those ideas and those tools and processes are the ones that will tend to rise to the top. And then it leads to employee satisfaction, right? Having a real sort of stake in the overall process, not just I'm writing this piece of code and I'm giving it off to somebody, they're building it, they're deploying it, and I don't ever think about it again, right? That doesn't lead to a lot of just sort of excitement about what you're working on. So being responsible for all of it, as well as the maintenance of it and building a good quality product, that's a benefit we've seen from it. All right, so what are some of the tools we use? These are all tools that I'm sure you're all familiar with. We use Slack quite a bit for communication, Jenkins, Puppet, GitHub. These are all pretty standard tools, I think, for most people. The ones I'm going to focus on today is Terraform. That's the software we use to sort of manage our architecture, build that out programmatically as code, and as well as keep track of it through Git, right? In the old days, you usually had some kind of document somewhere maybe to describe what the architecture was built like. Or maybe you had Puppet or Chef or something that helped you automate some of that. But coupling that with Terraform as well as managing it in Git, being able to do diffs against it, as well as tracking all that is a really powerful tool. So automation, that's one thing that I'm particularly interested in. And when we sort of set off on this project for this content platform at Bodybuilding, was a key part of it, right? If you've got to get on a system and do something manually even once, then you've sort of already failed. So everything has to be completely automated. This allows you to do lots of small deployments, not having to worry about batch them up, get in line, get in the queue, but just ship them whenever you want. And if you have confidence in your platform and the tools you've built and the automation, then that makes that really easy. Like I mentioned, 2,280 deployments last year. It leads to environment consistency. So one of the issues we had in the past is we release a new feature and we want to load test it, we want to perf test it. And so running a full-scale copy of your production environment is really cost prohibitive, and most of the time you're not using it. So it's tough to really get a good sense of how that application is going to perform once it's in production without being able to test it on like software. So what a lot of people do is they have sort of a scaled down system, they do some testing, and then they try to extrapolate from there what it's going to do in prod. And those of you that have gone through that know that that doesn't work really well. And so by automating everything and defining the infrastructure in code and maintaining that in Git and just having a full, clear view of it and a repeatable, and the ability to repeatedly execute that just lets you have as many environments as you want. You want a new one, spin one up, right? Just change a few properties in a property file and you're set. It also allows you to scale just through configuration. And then as well as through just incoming traffic, CPU load, right? The system should just be able to scale, come online, and just start functioning. And so again, spinning up 100 servers should be just as easy as spinning up one. If you've done the automation piece right, you don't even think about it. It's just something you get as a byproduct of doing that. And the last point there is the tagging strategy. And those of you that have used AWS, hopefully you're familiar with that. It seems like a minor thing in the beginning to worry about. How are we going to tag these systems? But in the end, the benefits that you get from this are really great. So I call this one out specifically, just in terms of, again, having systems spin up automatically, be able to be monitored, but as well as from a cost analysis point of view. Good tagging on your system really allows you to tie in your reporting and be able to get a really clear picture of what your application, what your infrastructure costs. And finally, monitoring. Just a quick dashboard of what we use, which is Datadog. And then we'll see this in action as we do the demo, so I wasn't going to cover a whole lot on that. So this was really one of our test projects that we did when we started moving to a DevOps model, is we had an old, aging, really in-house built content management system that was just kind of cobbled together over the last 14 years or so. About 40,000 articles, 500,000 assets, images, documents, 30 million plus visitors a month. And we were able to migrate that over into a new system, as well as move it completely into the cloud. So all those tools that you saw on that screen, with the exception of Slack, were all new to our company. So by empowering these teams and allowing them to have the flexibility to be able to choose those tools, they were able to build those systems out.